Okay, we're ready.
All right. Should we start?
Yep.
Right. Okay, get the first one. That is the easiest one. It says, what notation is used to denote the probability of an event occurring? The answer is P parenthesis X.
Perfect.
Are we supposed to do part 1 and 2 or just part 2?
Just part 2.
All right, well, let's do part 2 then. Which? All right.
I think we're okay as long as we understood the first 4. I think that we can just go straight to part 2, right?
Yeah, it's pretty basic questions. Okay. Yeah, it's pretty basic.
Okay. So we just need to do 5 and 6 and take the quiz tonight then, right?
Yep.
Yeah.
Okay.
All right,
So for 5, I can do it.
Okay.
An 8-sided die has 8 possible outcomes for each roll. 1, 2, 3, 4, 5, 6, 7, or 8. Calculate the probability of rolling a number greater than 5. So you'd have 3 out of 8 because you'd have 6, 7, or 8, correct?
Yep.
Yeah,
So
that
37.5%.
Yep.
Okay. What do you
6.
guys have for 6?
Can I?
yeah.
Yeah.
Okay, 6. Calculate the probability of not getting a number greater than 5. It's 62.5%.
Correct.
Yep. Good job.
Right, bless you. Okay, let's jump to the quiz.
Okay.
Okay.
As usual, the first 2 are the easiest.
All right, the first one says, human blood can be classified into one of our basic types, OAB and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following types: blood type, OAB, AB in the columns, Pretation O is 0.45, A 0.40, B 0.11, AB 0.04. Says the question, the blood type and the proportions given in the table above define a probability distribution.
True. Because they all equal 1.
Right.
Right. Okay, what's the probability that a randomly select person in the United States has type O blood? Round to the decimals.
0.45. That's like the
So then question 5 would be 0.55, correct?
Yeah.
Question 5 will be 0.55.
Right.
Mm, I
Right.
think I'm-
We all good?
Yeah. Yeah.
Yeah.
That was an easy one.
Okay, so I'll read the next one if you want.
Okay.
Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tingle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability they will correctly identify the dish containing the specimen from the bladder cancer patient? So it would be 1 in 7, which would be 0.14, right?
Yeah, I think it says to 3.
No. Oh, it wants 3. Oh, sorry, 0.143.
Yeah.
what?
But yeah.
So
Okay.
1 in 7, Melina. So if you divide 1 divided by 7, you get 0.143.
Yes.
Got
yes.
it?
Yes. Okay.
Okay.
Mm-hmm.
Okay, I guess I can read the next one. It says, in
Okay.
a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? A, this provides strong evidence that dogs can detect bladder cancer, and B, there is little evidence that dogs can detect bladder cancer. I think it'd be A. I mean, if they did it 22 times.
I'll go for 8 too. Yes.
Okay.
All right. Do you want to go for the next, Melina?
I'm so sorry because I don't know. I didn't listen. This 7. The 7, the answer is there is little evidence that no.
Are you asking on number 7?
Yes.
So we decided that because they chose the right one 22 out of 54 times, it would provide strong evidence that they can detect bladder cancer. So we picked A.
Okay. Point 2.
Rich.
Mm.
We're doing 8, right?
Yeah.
Okay, just making sure.
Does somebody want to read it, or do you want me to?
I can read it.
Okay.
M&Ms are smaller chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table: color and proportion. Brown, 0.13, yellow, 0.14, red, 0.13, blue, 0.24, orange, 0.20, and green is the question. Okay. If you reach in the bag of plain M&Ms, what is the probability of drawing a red colored candy?
0.13.
0.13.
And then the next one, what is the probability that a randomly selected candy is green? So if you add those up and subtract from 1, you get 0.16, correct?
Yep, that's what I have.
Okay.
And then if you basically do that minus the 1 again, it's 0.84. And that's for
Right.
number.
So 0.84 for number 10.
Yep.
Good, Emmanuel.
Yeah, I got those.
Good, Melina.
I got those.
Mm. Uh, the 9.
And the 9? What's the question?
Yes. Yes. I use the there is 6 colors in the and it's just one color. I put the 1 to 5 colors.
Okay, so
And
you did 1 divided by 5 on that one?
and and I put the 0.17.
Okay, so the reason the answer is 0.16 is because in order for it to be a probability, it has to be, everything has to be equal to 1. So then if we add the, the proportion for the brown, the yellow, the red, the blue, and the orange, we get 0.84. So then what's left over has to equal 1, and that's 0.16. And that's why green is 0.16. Does that make sense?
Okay. 16. Okay. Okay. 11.
Number 11.
Okay.
Okay.
All right. Use the following information to answer the next three questions. The ACT score of students admitted in the medium-sized public universities in the Western Union states were taken from HIPEX.com. The following information statistics were calculated. Mean 24.3. Do you want me to read all of this? No, right?
Now we can see it.
No. All right. Okay. If of the observation are less than or equal to the number. Okay. Half of the observation are less than or equal to what number? Oh.
So wouldn't it be the median? 24?
Yep.
Yeah.
24.
Yeah.
Oh, yay.
Ready? I can read number 12.
Okay.
Says, based on the information on the table above, the top 25% of the students scored above what number? So that one would be the Q3, the quarter 3 percentile. So I'd say 27.
Yeah, I agree.
Well, it's Q1, medium, Q3, right? So it will be based on the information table above, top of 25% students score. Yeah. All right. Question 13. Which of the following statements is not one of the three rules of the probability? Okay, let's check my paper.
I have C for if the probability is high,
Yes,
then the
if the
probability is
probability is high,
positive. If the probability is low, then the probability is negative. Does that make sense?
Right, because you can't have a negative.
Yes.
Yep.
All right.
Yeah.
Perfect.
All right. Looks like, did everyone already submit it?
I just did, yep.
I did.
Okay. Yes.
Yes, Melina.
No, it's okay.
Oh.
Just
Good deal.
I just have a.
All right, guys. We're gonna be using the, what is it called? Just barely saw the video posted by the teacher. Or lesson 5. So we're gonna use in the one of the charts that the one that looks like a mountain. I don't remember what the name is. It's called like what? Just watch the video. I'll explain you a little bit how it goes for the next week meeting on the homework and everything. So it's kind of useful for the next week, not for this one.
Okay.
So.
Okay.